Hi, this is Lou Covey, Editorial Director of Footwasher Media with a NewTechPress report on FPGA verification. And I'm here with Brad Quinton of Tektronix. Hi, Brad.
Hi, Lou.
So, what is it you do at Tektronix?
What I do at Tektronix is I am in charge of the technical direction for the embedded instrumentation group. And so this group is based on adding embedded instruments to FPGA and ASIC designs to basically restore the visibility that's been lost during this huge drive towards integration, where we see huge amounts of functionality moving on to a single chip. And this is currently, we're very focused on digital logic, but this is even a potentially broader move into overall embedded instrumentation.
Okay. Now, is this a fairly recent group at Tektronix?
So this is a brand new group at Tektronix. Tektronix purchased the company that I founded after finishing my PhD at the University of British Columbia.
That would be Veridae.
Veridae. And that, myself and a group of 3 other guys came together around the technology I developed during my PhD, form a company, Veridae. We'd been around for about 2 years. We had products on the market, customers just ramping up, and Tektronix went ahead and purchased us. So around that purchase, Tektronix has built the embedded instrumentation group.
Okay, but as FPGAs have become much larger, rivaling the scale of the most complex ASICs, FPGA verification has become extremely important, and a very popular and well-populated market. So what I'd like to find out from you is, where do you see the industry as it stands right now? Where are the strengths? Where is it heading? And what are some of the things that you still need to be working on?
Sure. So one thing I would start with is I actually think you can actually look at 2 aspects of FPGA verification. The way we look at it is actually there's people building FPGA-based systems who have verification issues, and those tend to be tied up with their whole system. And then there's what you were hearing a lot of at DAC, which is very focused on FPGA prototyping of ASICs. Now, fundamentally, both of those groups are still doing debug, but they do have significantly different goals. The people doing FPGA prototyping of their ASICs, they're trying to accelerate verification. They want their designs to be correct before they tape out. The reason they're using FPGAs is to get the throughput in verification, because they can't simulate enough. They can't simulate long enough. And so what you see there is very complex designs mapped across many FPGAs. And so many clock domains, lots of functionality. These are big ASICs that just happen to be across big FPGAs. So it's actually fairly easy to test those products, because you plug them into the regular I/O stimulus they're destined to be with their ASIC. But it's extremely difficult to understand what's going wrong when you actually run into a bug. And so there's been a big push, as you saw at DAC, to say, okay, now that we've got designs on FPGAs, now that we can test them much better, how do we improve our productivity during the debug process, so we don't spend all of our time staring at these giant FPGA boards, wondering what it is that we're missing in our simulation. And Veridae's position and Tektronix EIG's position is that the big problem is internal visibility. To get true internal visibility into what's happening inside each of the FPGAs, and seeing how those FPGAs come together to give you a view of what's happening in the essentially system that you've implemented on your ASIC or across these FPGAs. And so some of the fundamental issues there are dealing with these different functional units running at different clock frequencies and getting a complete synchronized view across all of these independent but cooperating units in your system. The other problem that people find with debug of FPGAs in general, and especially ASIC prototypes, is that if you have to recompile or resynthesize every time you want to debug a different part of your design, it can take you 12 to even 24 hours every time you're trying to make some new debug step. And that just drive the productivity out. All the productivity gains you're getting by running your tests much faster go away as you spend all trying to be productive and debug. It's kind of where we see that space, and we have a product targeted specifically to that called Certus. We also see a different market, and that's the FPGA-based systems. And as you said, FPGAs have gone this little bit of glue logic that were used in systems between ASICs to being, in many cases, the heart of some digital systems. And in that transition, the onus on verification for FPGAs has changed a lot. It used to be that people would actually just throw the design onto the FPGA and see if it worked. But once you have an embedded processor, many different clock domains, you have different cores like USB, PCI Express, all running essentially independent. It's not sufficient to just throw it into the lab and see if it works. If you do that, you'll spend all of your time just scratching your head. So again, though, that problem comes back to seeing what's happening inside your FPGA across all of these different clock domains, across these functional units. And that's where having sophisticated embedded instruments can really help for you to get that observability that you really need on chip.
What's the future? What are we still missing in this area that we need to be looking at?
Well, so I actually think we're getting close on the process of how do we put instrumentation into a design now. We've gone a long way down there. There's some other people who are pushing on that. I think now the big push is what do we do with this data? Now we can see what's happening on this internal bus and that internal bus, and we can see what's happening in the software state. People are still saying that's great, but now how do I know what that means to my overall system? How do I deal with all that data now you've gathered in a way that's meaningful to me so I can quickly pinpoint the problem and move on? It's very rare now that you're seeing a problem is that someone created an adder that doesn't add. Those problems are all abstracted away. Now these problems are my software interrupt routine is too slow in this strange scenario. And so when you get your debug data now, if it's very low level and raw, it's very difficult to map that back to that higher level problem. So I think that's the next big direction.
And how close are let's say, Tektronix to that?
Well, I think Tektronix, interestingly, has all of the pieces to put that together. It's an interesting thing because Tektronix has not only logic analyzers, of course, but protocol analyzers, oscilloscopes, an array of different ways to gather data and present it to the user. And so now, if you think about embedded instrumentation as just one more aspect of that problem, you can see that there's the ability to leverage existing methodologies. For instance, if you look at a PCI Express protocol analyzer, it doesn't say this signal went high on this clock cycle. It says this transaction occurred, that transaction occurred, the training sequences happened here. It's much more of a high-level abstraction. So I don't think anyone is actually delivering that today for FPGAs, but I do think some people are close to being able to deliver something like that.
Anybody in particular?
Other than us? No, I wouldn't want to comment beyond
All right, sounds good. Well, Brad, thank you very much. This has been highly illuminating, and I look forward to seeing what Tektronix is going to be coming up with in the next year or so, now that you're on board.
All right,
this has been Lou Covey with NewTechPress Report. Thank you for listening.